from advanced functions, in which we're asked to create a graph with three things. So we want the instantaneous rate of change at x equals 2 to be 0, the instantaneous rate of change at x equals 3 to be less than 0, and the average rate of change on the interval from 0 to 4 to be 0. So let's unpack this a little bit. So we need an instantaneous rate of change at x equals 2 to be 0. Well, what does this mean? Well, it's important to know, we should recognize that the instantaneous rate of change at a point is simply the slope of the tangent line that meets the graph at that point. So there is exactly one line which passes through that point and then diverges on either side from a curve. The slope of the tangent line, right? So how steep is a curve at that point? So the instantaneous rate of change, or the slope at x equals 2, is 0. So we need 0 slope. We need something flat at x equals 2. So we'll just put a little flat line, horizontal line there that goes through x equals 2. Now, check. We need the instantaneous rate of change at x equals 3 to be negative. So we need a negative slope, something going down at x equals 3. So we're just going to put a straight line down through x equals 3. Check. And now we need the average rate of change on the interval between 0 and 4, including both 0 and 4, to be 0. And now this is a little different from the instantaneous rate of change, which is at one point, the tangent line at one point. Here we have the average rate of change is actually going to be asking us how much is the graph changing over a larger period, in this case between 0 and 4. So it's basically asking us, how can we make sure that the graph doesn't change at all between 0 and 4? And the obvious answer is just put 2 points, one at x equals 0, one at x equals 4, at the same height. But let's just dig into this just a little bit to really understand what's going on. So the average rate of change, well, that's how far you've gone up or down compared to how far you've gone left or right, or slope, rise over run, right? So here's your slope formula, y2 minus y1 divided by x2 minus x1. Now we know what x2 and x1 are. They're given to us here. So this is going to be y2 minus y1 divided by 4 minus 0, which is just 4. And we want this to be equal to 0, right? This we need to set equal to 0. Well, that only happens if and only if y2 minus y1 equals 0, which means that y1 equals y2, right? And so this just reinforces what we already knew, that at somewhere on the line x equals 0 and on the line x equals 4, we need to have the y value of the point on those lines. The y values of the points need to be the same. They need to be at the same height. So we're just going to continue this line all the way down to 0 at x equals 4, and we'll take this line all the way down to 0 at x equals 0. And check, we're done. If you don't like the kind of trapezoid look of this one, if it looks a little too cuspy for you, a little too disjointed, a smoother example of this, just so we know, remember what we've done a 0, we've done a negative, or maybe we'll do less than 0 slope here, and then these points are equal in height. But a better, cleaner looking graph would do the same thing, right? So that's 0. This is at x equals 4. We know the graph is going to go through those, and we want it to be a little smoother. Well, a graph that goes through 0 and 4 has roots at x and a root at x minus 4. And then if we want the graph to slope downwards in general, if we want it to be what we call concave down, then we need to put a negative out here. So this would actually end up being negative x squared plus 4x. And at x equals 2, it's up here somewhere, wherever this scale would put it. And this is a pretty nice smooth curve that it'll continue to go down, but it satisfies everything on that interval. So there you have it.